All right, good morning. We're doing the whiteboard thing today because we're going to talk a little bit about how we're going to program this before we actually get into the source entities to do it. So the way I generally approach trying to program some game logic is I walk myself through all of the steps that are required to make it happen. So I ask myself, like, what is the first thing that has to happen when this event is going to take place? So the first thing that's going to happen is the player presses a button, right? So we're going to kind of flowchart this. So the very first thing that happens is the player is going to press a button, okay? So they press a button. Now, our combination code is going to have 4 digits in it. So every time the player presses a button, I need to count that button press. Even if it's not a correct button, I need to count that he pressed a button so that when they get to 4, I can figure out if they got the right combination or not. But nonetheless, every time they touch a button, I have to count it. So after they press a button, I am going to add +1 to the total button count. Okay, so that's what the math counter, we have 2 math counters, right? So one of them is just counting button presses. So they're going to press a button, and the very first thing we're going to do here is we're going to count that button. All right, that's button number 1. Now after we press that button, then we need to look at it. So after we count that, then we're going to go to our comparison. Okay. So we press the button, we add 1 to our total count, then we're going to look at the button and see if it's the right button. So if it is the right button, we're going to go ahead and add 1 to the correct count. Okay? So what that means is when the player presses the button, we count that, all right? So they can do 4 presses, so we're going to count that. Then it's going to take that button and it's going to look at the number that they pressed and check to see if it's the right button for the first button press, right? Is it the first digit of our code? If it is, it's going to go over here and it's going to add 1 to the correct counter. So I have 2 math counters. I have one that's counting how many buttons they've pressed. Doesn't matter what the button is, it's just counting 4 buttons. The other math counter is keeping track of how many they got right. So the first one, if they get it right, then what we're going to do is we're going to go ahead and we're going to reset the comparison . Okay. So what I mean by that is when the game starts, this compare is looking for the first digit of the code. So my code is 1423 in the sample. So when the game starts, the compare node is set to look for the number 1. So if the player presses 1, it's going to come over here and it's going to say, all right, you got 1, so we're going to add that. Then it's going to set the compare so that the compare starts looking for the next number, which would be 4. And then it's going to loop back up. We're going to come back up here to the top. And we're going to wait for them to press the button again. So when they press the button, it's going to add. So now our count is at 2. It's going to compare again. So now it's looking for the number 4. If it's right, it's going to come over here. It's going to add another 1 to the comparison. And then it's going to reset it to the next number. So this is going to tell the comparison, all right, now you're looking for the number 2. Goes back to the top. We're waiting for the player. Now, if it's a no, if it's the wrong number, no big deal. It's going to come back over here. Okay? Now, when this thing gets to 4, we need to stop it. So right here, this math counter, when it gets to 4, we're going to have a little question right here. If this gets to 4, if this is a no, we're going to allow it to go in here and keep going. If it's a yes, we're going to check their code. Okay? So the way the whole logic with this works is they press a button, any one of the 9 buttons, and it's going to add 1 to a count. Then it's going to check to see, is that count 4? So once we've hit that 4th button, it's going to check to see if this code is correct. If they're not at 4, if it's 1, 2, or 3, it's going to keep checking the buttons. So if it's the right button, it's going to add to this one, and it's going to reset and come back to the top. If you punch in the wrong button, it's going to keep going, but it's going to let you put in 4 buttons. So the thing about this way I have this set up is the player gets no indication if their code is right until they've hit the 4th button. So they'll press a button, it's going to add 1. If it's less than 4, it's going to keep comparing. Once we get to 4 on their 4th button press, it's going to go through and check their code. All right? So let's look at how it was done inside the editor. So let me switch screens here. All right. So we've got our nodes here. Now, interestingly, the way the pictures for the nodes look is they actually kind of look like a flowchart, which is kind of nice. So yesterday I asked you to put in a door. I asked you to put in a logic branch, a logic compare, a math counter, another math counter, 9 buttons, and then this keypad thing. So the keypad thing really doesn't do anything at all, so don't worry about it. It's just a prop. If it's giving you an error, I had a student in another class that was giving him an error. You really could take it out. It doesn't matter. You would need to put a material on your buttons so they show. But basically the buttons are no draw if you have this. If you don't have it, then you'll need to put a metal material on them or something like that to make them look like buttons. All right, so we're going to start with the buttons. So all the buttons are initially going to get kind of the same programming on them. So let's check our names of all our objects, and then we'll go through the outputs. So we'll start with the door. So the door's name is keypad door. Has a lip of 4. And under flags, it's toggle. Nothing else is checked. All right. My branch, my logic branch. The name for that is key branch. Initial value is 0. Okay. Now remember what this branch does. The branch is simply an if statement. It's a true or false. So 0 is false and 1 is true. So initial value is false. Okay. No flags. Really simple node. The logic compare. So this is what's going to check all of our numbers. Every time we press a button, this one compare is what's going to check them. So this thing, its name is key compare 1. The initial value is 0. And then the compare value, so this is the number you're looking for. This is the first digit of your code, okay? So let's go ahead and make this one, let's use 1, all right? So that it matches up with my original sample, all right? So we're going to name it key compare 1. The initial value, so this is the value that you pass it from the player. The compare value is the value that it is storing inside. It's holding it for you. So this number right here is the first digit of your combination. Go ahead and apply it. And we have 2 math counters. So one of them is going to keep track of every time you press a button, and one of them is going to keep track of every time you get the number right. So that's why we have 2 of them. So this one is called keypad count presses. So what this one does is it is counting every single time you press a button. Right or wrong, it's giving you 4 button presses. All right? So for this, start disabled, no. Initial value is 0 because we haven't pressed any buttons. The minimum legal value is 0. We don't need to worry about that. The maximum legal value is 4. So this is the number of it's the number of numbers in your combination. So it's 4. When we press 4 buttons, this math counter is going to hit its maximum and sort of like initiate the check. Okay? Nothing on the flags. Apply it. Our other math counter is called Keypad correct count. So what this one is doing is keeping track of the numbers that you get correct. So when you punch them in and you get them right, this one gets to go up 1. So it's going to be disabled no, initial value 0, minimum legal value 0, maximum legal value 4. Because remember, there's 4 numbers in our combination. So if you get all 4 right, this guy's going to hit its maximum. Okay, so these two things do different things. This counts every button press. This one counts every correct button press. Go ahead and apply. All right, so everything's named. We've got our 4 entities here, our door. So now let's look at the buttons. All right, so you should have 9 buttons. So let's open up the first one. So the buttons, we named them Keypad 1, 2, 3, 4, 5, 6, 7, 8, and 9. We gave them a sound, this little small dupe here. Delay is 0. That makes them reset as fast as the game will allow. Flags is going to be don't move, and use activates. Now, on the buttons, all of them, all 9, on the output, we're going to get this right here. We're going to click add, on pressed, keypad count press, add 1. So you'll have to manually type in this 1 right here. So what this does is when you press this button, it's going to go to the keypad count press, which is this guy right here, this math counter, and it's going to add 1. All right? So all 9 of your buttons get this right here. Because remember, if you press any button, we want to count this guy right here. All right? So all 9 buttons are going to get on pressed, keypad count presses, add 1. And you're going to do that for all 9 of these buttons. So if you click through my buttons, you can see they're all marked the same. All right, so pause the video, set up all your buttons, and then I'm going to switch to a different map, same map, but it's got my buttons configured. So pause the video here and then go ahead and come back after you have all your buttons with an output on them. All right, so here I am, same setup. The only difference between this map and the other one is I had cleared out all my buttons so that you guys could see them as blanks. All right, so let's look at the buttons that are the secret code buttons. All right, so on mine, the code is going to be 1, 4, 2, 3. So it's this one, and then after this one, you have to press 4, then 2, then 3. So those buttons get a little bit of extra special output on them because they are in charge of telling the comparison what number to be looking for as the game goes on. So if you remember my logic compare, this guy right here, this compare value is the first digit of the combination. So the first number of the code is 1. So let's go look at button number 1. All right, button 1. So button 1 has 2 extra outputs on it. So the first one, on pressed, keypad, count presses, add 1. So this counts that we pressed a button, any button, okay? On pressed, key press 1, so now this is talking to the comparison. And it's going to set value compare to 1. All right? So if we look at our comparison, so here's my, that's my math counter. Let's look up at the comparison. There's some comparison. Okay, So this value right here is 0. When I press this button, it's going to set that value to 1, and then set value compare. What that means is that it's going to go to this comparison, it's going to set this value to 1, and then it's going to compare these two numbers. Okay? Then it's going to tell the comparison what the next number of the code is. Okay, so my first button is going to set the value to 1. Then, after it does that, with a delay of 0.01 to give it time for the code to run, it's going to talk to the comparison, and it's going to set compare value to 4, because 4 is the second digit of my combination. Okay, so if we go back to the comparison here, I have two values. I have this value and I have a compare value. So when I press this button right here, this number 1, it's going to set this value to 1, and it's going to compare them. So 1 and 1. That's good. Then this button is going to set the compare value to 4, because the next button in the combination is 4. So it's telling the comparison here, all right, the next button you're looking for is number 4. So it sets this up to look for button number 4. Okay, so on my button, I have an add, and then I'm going to compare after I set this value to 1, so that number 1 gets set and it compares it. Then it's going to set the compare value to 4. So now it's setting the comparison to be ready for the number 4 button. So now let's go to the number 4 button, okay? So your 4 buttons that are part of the combination, they have extra capabilities because they're in charge of setting the combination. So my first button is 1, so now let's go to 4. So number 4 is going to do the same thing, on pressed, keypad, count presses, add 1. Then it's going to set the value to 4 and do a comparison. Then it's going to set the compare value to 2. So my combination is 1, 4, 2, 3. So if we look at button 1, here's button 1, and then it tells us that the next Alright, sorry about that. Spam caller here in the morning. Alright, so button 1, it's going to set the value to 1 and compare number 1. Then it sets the compare to 4. So now the comparison is waiting for the number 4 button. The number 4 button is going to set the compare value to 4. Then it's going to, the value to compare is going to be 4. Then it's going to set the compare value to 2, because this is the next number in the combination. Okay, so you can kind of imagine what's happening on the next one. So when I go to the second button, or the number 2 button, it's doing the same thing. It's setting its value to 2 to do the comparison. Then it's changing the compare value to 3 for the 4th and final button. So 1, this is the value we're going to compare, and then we're changing the compare value to 4. Then we go to button 4, here's the value we're going to compare, then it's changing the compare value to 2. Now we go to this one, it's going to set it to 2, and now we're looking for the number 3 button. So number 3 is the last one. So on the number 3 button, all we have to do is set the value and run a comparison against the number 3. Okay? But if you look at the way the buttons work, when I press 1, it then sets it up for the next button in line. So the next digit is 4. So here's the 4. Now if I go to the 4th button, you can see here's the 4, and now the next button is a 2. So I go to the 2, here's the 2, the next button is a 3. So I go to the 3, and the 3 is just all by itself because it doesn't do anything past that. All right? Now all the other buttons, they look normal because they don't do any comparisons on the other buttons. They're just there to look pretty. Okay? So the only buttons that we put outputs on are these ones. All right, so those are your buttons. So now let's go to our math counters. All right, so math counter, this first one. All right, so this is the one that counts my presses. So this one's really simple. On hit max, key branch, test. So what that means is this branch right here is true or false. This one, when you press 4 buttons, it's going to tell this guy to test to see if it is true or false, right? And I have a delay of 0.01 because I want this thing to give this guy a chance to talk to it first. All right, so all this thing is doing is when you press 4 buttons, this is going to say, all right, it's time to check the code to see if you got the right code. That's all this is doing. It's counting your 4 button presses. When you get to 4, it's going to check to tell this to test the code. It is testing to see if you put in the right code. Okay, so that's it. On hit max, key branch, test, delay of 0.01. All right, this one. So this is the one that counts if you got the combination right. It also has one output. On hit max, key branch, set value 1. No delay. So what this one does is if you press in the correct code, all 4 digits, it sets the branch to true. So remember, when we press 4 buttons, this is going to test the branch to see if it's true or false. This is going to set the branch to true or false. So if you press the wrong code, the branch is going to be false because this guy will never set it to true. If you punch in all 4, if you get it correct, if you get all 4, on hit max, key branch, set value 1. So remember, I said true and false, 0 and 1. 0 represents false, 1 is going to represent true. So when this one gets triggered, that means you punched in all 4 digits correctly. It's going to set this to true. All right, let's look at the logic compare. So the logic compare, again, very simple. On equal to, keypad correct count, add 1. So what the logic compare is doing is when you press a button, it's checking to see if it's the right number. If it is the right number, it's going to add 1 right here. That's all it does. So remember, it's looking for the number 1 first, right? So when you press the number 1, it's going to put a 1 right here, and it's going to compare them. So if those are the same, it's going to add 1 to the correct column. Then this number right here becomes a 4. So if you press the 4 button, this becomes a 4. So these two are the same. It's going to pass another number over here. So now this becomes 2. Then this will be 2. This will be 2. You get the correct number, it passes it. So every time you get the right number in the code, the logic compare is going to add 1 to this guy right here. So every time you press a button, this goes up 1. Every time you press the right button, this goes up 1. So these two things are separate. They're counting your button presses, but this one counts all button presses. This one only counts the correct button presses. All right. Now, all the magic happens in the branch. All right. And what I would recommend doing is I'm going to open it up and show you all the outputs, and then I would pause on that and copy them over. I'm going to explain them, but then you're just going to need to pause it to put them all in, okay? Because there are a lot of them. So I'm going to go ahead and move this out a little so we can take a look at it, and I'm going to just kind of explain what everything does, and then you can pause on this frame right here and copy it, all right? So what this guy does is he has 2 positions. He can be true or false. So false means that you put in the wrong code, and true means you put in the right code. And pretty much what needs to happen is it needs to reset the whole thing so that you can start over. If you got it false, if you got it wrong, and if it's true, we need to reset the whole thing, plus we're going to open the door. And I've got some lights in here that we can take out. If you don't have any lights on yours, you can ignore all the ones that say light. But we'll go ahead and go through it. So we'll start with the falses. All right, so when we get to 4, we've pressed 4 buttons. If the combination is wrong, this is going to be false. So what we're going to do is we're going to take the keypad correct count, set value 0. So what that means is it's going to wipe out any buttons you pressed in here. So this goes back to 0. You start over. Keypad count presses, set value 0. So what this one is going to do is it's going to wipe out this one. So we just cleared both of these. We put them both back to 0. Keypad model skin 2. If you use the keypad model, the same one as me, it has 3 skins. It's got a blank, an error, and an access. So it has 3 skins, 0, 1, and 2. So the number 2 skin is the one that says error on it. So if you get the wrong code, I'm going to show you the skin that says error. This is going to turn on a red light that I have. If you don't have lights on yours, you can skip this one. This one, on false, key compare, set compare value to 1. So remember, the first digit of our combination is 1. So I am putting this comparison back to 1 so that the whole code thing starts all over again. So this is resetting the combination so I can start over at the beginning. So I cleared this, and I put the compare back to 1. So it's now, again, looking for the first digit of my code, which is number 1. Okay? Key branch set value 0. It puts itself to false. Okay? Just in case anything happened, I went ahead and reset this thing too. So when we get to the 4th button click, all of these entities are getting reset back to their original position. Then we're going to set the key model skin back to 0 with a delay of 1 second. Okay, so what that does is, remember up here, we put the error code on the screen, and then after 1 second, a delay of 1 second, I'm going to put it back to skin 0, which is the blank screen. So this is going to reset the screen. And then finally, I'm going to turn off the red light. So if you do not have a light on your map, you can skip this one right here. All right, now that covers all the falses. The true is still going to do about the same stuff with the addition of opening the door. So the keypad correct count is going to set the value to 0. So we're going to clear this one. Keypad count presses, set value 0. So we're going to clear this one. Keypad model skin 1. So this is going to set the skin of the model to skin 1. And this one says access. I have a light that turns on that's green. If you don't have lights, you can ignore this one. Key compare, set compare value 1. So again, this is going to get put back to code number 1. So we're resetting all the logic back to the beginning. Okay, so same exact thing. Key branch set value 0. So this right here, I'm setting it back to false. Because remember, if we got the code right, this became true. So now we're resetting everything. We're putting everything back to the way it was when it started. So 0, 0. This is looking for button number 1, and the branches get back to false. The door, I'm going to open it. The keypad model skin, with a delay of 1 second, I'm going to put it to 0. So this is turning out, the word access is on the screen, so I'm putting it back to a blank screen. This is a light. If you don't have a light, you don't need this one. And then finally, I have the door closing after 5 seconds. So if the player doesn't go through the door, it's going to close after 5 seconds. All right? This is the whole logic that makes it work off of this branch right here. And that is it. That is a 4-digit combination. We've got a door, there's your logic, there's your buttons. It works. So let me know if you have any issues with it. And otherwise, that's what we're working on today.